How would you react if I were to tell you that there was something even more empty than space? You'd probably say I'm crazy, right? I mean, space isn't empty. There are planets, you have stars, there's galaxies, black holes, satellites, and as of right now, 10 humans hanging out in space. I would tell you that you're right, but you're also kind of wrong. Space is incredibly empty. It's about 99.9999999 repeating percent empty. The universe is so large that despite there being so much stuff out there, it's spread out so much that the average density is less than one hydrogen atom per cubic meter. You'd probably then ask me what would be more empty than space? Well, I tell you, it's the Large Hadron Collider. I know. You're probably thinking I'm crazy, but stay with me here. In part two, right, I mentioned that the LHC had a relation to John Fishman of the band Fish. Well, aside from a perfectly good excuse to mention one of my favorite bands, both utilize a vacuum to do their thing. But don't worry, I'll save the vacuum cleaner tutorial for my music page, PJK Music 27, shameless plug. Unless, of course, you guys really want to hear it. Anyway, inside the Large Hadron Collider's beam pipe, which is that 17-mile-long tunnel we talked about, is an ultra-high vacuum. The pressure in there is roughly 100 billion times lower than Earth's atmosphere. Only a handful of molecules are going to remain in there. It's really meant to mimic the conditions of interstellar space, where you can go vast distances without hitting anything. Now, this is where Sir Isaac Newton rolls up. One of the first things you're going to learn in science class, of course, is the law of inertia. An object in motion tends to stay in motion unless acted upon by an outside force, otherwise known as something gets in the way. Unfortunately, on Earth, there's always something getting in the way. There's air molecules, there's dust, there's random other stuff, there's cow farts. But since the Large Hadron Collider is an almost empty vacuum, there's nothing to hit. In other words, imagine you had Shohei Ohtani at Dodger Stadium in Los Angeles trying to throw a ball to his catcher behind the plate at Citi Field in New York without hitting a single thing on the way. That's what the LAC is trying to do. And of course, in this scenario, one of the Mets would probably be the batter, and they're not really hitting anything anyway. So I guess that's not really a good analogy there. Anyway, though, you're probably thinking, how can this be true? Wouldn't they smash into the walls of the LHC? They won't, because that's where the magnets that I mentioned in the previous episode come in. These particles travel around the tunnel at 11,245 times per second, with a single trip taking less than 90 microseconds. They leave it on for 10 to 15 hours at a time. So what happens is they circulate these particles about 600 million times around that 17-mile track. This whole time, they're being steered and guided away from the walls using those superconductor, super cold magnets that we talked about previously. It's kind of the, I guess would be the quantum world equivalent of being stuck in a Waymo that's doing donuts. All of this effort, though, the giant tunnel, the extreme cold, the near perfect vacuum, it exists for one single reason, and that is smashing particles. And in the next episode, we're going to finally talk about it, and it is really cool.